When finding domains and ranges of functions, it's easiest to do this if you're able to recognize the graph. And if we can't recognize the graph, we use our graphing utility as a tool to graph and find out what the function is looking like, what it represents on a coordinate plane. So our first example, 14a, says f of x equals the square root of 3x squared minus 5x minus 28. So our domain, we know we have to be concerned with that domain because 3x squared minus 5x minus 28 needs to remain positive. So algebraically, we can do this calculation right here where we're going to try and factor this. So I'm going to try and factor and come up with my critical values. I'm going to try 4 and 7, and I think that's going to work. I'm going to put the 7 here and the 4 here, and I need a negative 5x, so that should factor right. Negative 12x plus 7x is negative 5x. So my critical values on the number line are negative 7/3 and positive 4. So you can equate this to the x-axis. And this value right here is going to be negative 7/3, and this value right here is positive 4. I could have really changed the settings on this graph a little bit better because we're going from negative 50 to positive 50. Probably don't need to go that far out. But it is what it is. So all of these inputs from negative infinity to negative 7/3 and then 4 to positive infinity. So all of these inputs will give me positive outputs. And that's what we want. We want positive radicans so that we can actually calculate the square root of that positive number. So looking at just the quadratic, 3x squared minus 5x minus 28, we want to keep that positive. And negative infinity to negative 7/3, 4 to infinity is going to give us those values. And we can test values by putting in a negative 10. And then we put that negative 10 in here, and we get a negative times a negative is a positive, and positive numbers are greater than or equal to 0, so that's going to make this true. And then we can try putting in a 0, put a 0 in. So if I put a 0 in, I get a positive. If I put a 0 in here, I get a negative, and a negative is not greater than or equal to 0. So that's going to give us a false interval right there. And then we have our last interval to try. We put a 10 in, and we're going to end with a positive times a positive, and that is a positive, which is greater than or equal to 0, so that will be true. So our domain goes from negative infinity to negative 7/3 and 4 to infinity. So those are the two intervals that encompass the domain. Now, what are our outputs? And we can actually, let me go back here. This is our domain right here. Once you graph the original function, once we graph this original function, we can just look at the picture. We don't have to do the algebra that I just did. We could just look at the picture and say, okay, these are all the inputs that are going to give me valid outputs. And you can use the root feature of your calculator to calculate that value, which would be an x-intercept, and this value right here. So the x values of those roots are going to be your critical values. Now our outputs are going to be what we call the range. And our outputs for this particular function, we have outputs that start at 0 and continue to go up to positive infinity. So our range is representative of all of the y values. So our y values are along the vertical axis. So we would get 0 out, would get all the way from this 0 out, right, all the way up to positive infinity. So 0 to positive infinity. And there's our domain and range. Okay, so let's try the next one, and we'll just look at the graph this time. So here's our graph, x over the absolute value of x. Now, x over the absolute value of x is almost the same thing as x over x, and anything over itself is 1, right? So that's where these values are coming from. All of our outputs are going to be 1 when we put in a positive x value into our function. Now, the denominator, whether we put a positive or a negative in, is going to become positive. So it's always going to be positive. But when we put that negative value into the numerator, we no longer have a positive in the numerator. We're going to have a negative in the numerator. And when we put that negative value in the denominator, we're going to still have that positive. So we're going to either have, when we put in a positive value, we're either going to have this portion of the graph, right? But if we put in negatives, and I'm going to clarify this in just a second here. There we go. And if we put a negative value in for x, we're going to have negative x over positive x. Anything over itself is 1, but a negative x over positive x isn't going to be positive 1. It's going to be negative 1. Okay, let's lock that in there. So we're going to get, if we put negative values in for x, we're going to get a negative 1 out. So our domain is going to go from negative infinity to 0. Now, why is there an open circle at 0? Why is that not allowed? Well, because you can't have 0 in the denominator. So I'm going to be able to put in any number I want except for 0. So that's where our domain is going to come from. So the domain is negative infinity to 0, and then 0 to infinity. We can also say x such that x is not equal to 0, and put that in braces. Now the range, there's only 2 values for the range. We're either getting a 1 out, or we're getting a negative 1 out. See, these are all negative 1s. All of those are negative 1 outputs. So if I'm looking at my ordered pairs, I put a negative 1 in, I get negative 1 out. If I put a negative 2 in, I get negative 1 out. If I put a negative 4 in, that's a 4, negative 4 in, I get negative 1 out. If I put in negative 1.5, I get negative 1 out. So our output is negative 1 when we're putting in negative inputs, and when we're putting in positive inputs, our output is positive 1. So our range, which is comprised of the outputs, is just 2 values. So we can't use interval notation. We have to use braces to just list the values. So these are called braces. And then my favorite one, the quadratic formula, or the quadratic equation, a quadratic function, is a parabola. It opens up, it opens down. This one's opening up. So our domain for all quadratics is negative infinity, positive infinity. There's no denominator, no radical, so no problem. So our domain is negative infinity to positive infinity. And you can see that we can put in any negative number, square it, we're going to get outputs, right? And we could put in all of these values to the right side of the U. We'll call it a U right now, or the parabola, and we get outputs. So our domain is negative infinity to positive infinity, or we can say all real numbers. And that's how we write all real numbers. The range, we have to really look at the range now. The range has a minimum value, so it's got a low value. It's got a low value, whatever that y value is right there, that's its low value. And then all of the outputs are above that low value. So this is opening up, so all of my y values are going to continue to get larger and larger and larger the further away from the vertex that I get. So here's my vertex right here. Now the y value of that vertex is negative 0.25, which is negative 1/4. So my lowest value, remember in interval notation, it goes low to high. So my lowest value is going to be negative 1/4, and I'm going to get an output at negative 1/4. It's going to be the vertex, but every other output is higher than that. So my outputs are going to go up to positive infinity. So hopefully that helps you determine domain and range of different functions, and I would encourage you to use your graphing calculator. For the purposes of this video, I used Desmos to graph these functions. You can explore Desmos on a computer, or you can use your graphing calculator.